Hello, everybody. Welcome. How we doing? This is Tutor Justin, and this is the YouTube channel on how ChatGPT or different AI tools can help students, teachers, professors, parents, friends, anybody in this educational space, how it can help you solve a problem, solve some homework, help with an exam, study with an exam, all everything that encompasses in trying to get an A on a course. We have been going through our math series, and this week we'll have a three part episode on calculus. The first one, all on derivatives. So this first video will just be simple derivatives. Can ChatGPT how does it explain what a derivative is, how you use it, the product rule, the quotient rule, the power rule, just the basic fundamentals of a derivative? That'll be the first part. The second part will be a little bit more difficulty. The difficulty level will be a little bit higher, talking about logs, talking about the quotient or the chain rule, how to do exponentials, and then the last video will just be application based. Why the hell do we need to know what a derivative is, and when are we going to use it? When the fuck are we actually going to use it? So just strictly application based would be the third part of the series, and I'm really excited about these videos. Everybody, like the derivative really goes between a lot of different areas of some type of math in any type of college class. I've done a derivative in just your math class, your stats class, your economics class, physics, any type of science level of class. You're going to do some type of derivative, and ChatGPT will show you, does it do a great job of the foundation? And if you've never heard a derivative, are you really just going to grasp what it is and how to use it? Probably not. Why? It doesn't replace going to class. That first interaction of what a derivative is in the classroom setting beats everything else. So again, when the olds tell you don't use ChatGPT, they're just lying to you. It's a great tool. It doesn't replace going to class. Again, it doesn't replace, but that study aid, that assistant right there, that person that's there to do a refresher at 2 a.m., 3 a.m. when you're cramming for an exam is there and very helpful. One thing that I've learned that is fantastic is you might have taken a calculus class 2 or 3 years ago, 4 semesters ago. You did it back in high school, and then you go to this advanced economics class or this upper level class in physics, and you're trying to remember, what did I learn, or how do you take a derivative? I, for the life of me, can't remember. Boom, this is there. Do a 5-minute refresher, gives you all the rules, and I'll show you how it just really lays everything out very nicely. So it's a good refresher, especially in those moments. So I'm really excited about this. Don't let the teachers tell you, if the people that are cheating on there, they're going to cheat. They were cheating regardless. It's not, I don't really see a statistical difference in the percentage of people that are actually cheating, because the people that go to the ends of the earth to cheat will always cheat. And that's just how it is. I call that the 95-5 rule. 5% of the people fuck it up for the other 95%. And that's just how it is. I think this is a great tool to use on your homework. Homeworks are normally 10, 15, maybe, if you're lucky, 20% of your grade. Not that much. You could do excellent on the homework and terrible on the rest, and you're not going to do well in the class. So therefore, when you do well in the homework, you should do well in the homeworks, because you should be able to provide them with the correct answer every single time. But that's really not going to help you on the exam. So this is a good tool of really helping you study and learn the material. Again, we're going to be talking about the calculus, how to take a derivative. I hope you guys enjoy it. And here we go. Okay, so here's our worksheet with our derivatives. Again, this is the part one of a 3-part series, and we're just doing the basics we're not doing very complex ones. We're just going to break down a derivative at the beginning level, right? The very inception of a derivative, and just basic power, product, and quotient rule. We're going to see how ChatGPT can explain what a derivative is. And I do not think this is the best way of learning something for the first time. I still think going to class and learning from a professor or a teacher is the best way in the beginning, and then afterwards go to a YouTube channel like this one or different YouTube channel on how to actually enhance that learning. If you're still not understanding how to if you're still not really understanding what areas are you not understanding, how can you fulfill those and practice problems. Sometimes it's I think I get it, but then you go to the exam and it's completely different. Well, ChatGPT, this is a great way of learning, of providing some type of practice problem so you can be prepared for the exam, because they will provide you with an endless amount of practice problems. So let's get started here. So again, I understand that not many professors now provide worksheets like this. So you just, you're going to sit here and write down your derivatives or anything here and what the answers are. I understand that. But that doesn't make a difference really on how to use ChatGPT. Because even if it's written like this, or if it's on a browser on Pearson or Blackboard or Canvas, the process is still the exact same. I still think that learning math and uploading math in a multiple choice setting, or just putting the answer down in a question on Pearson, is still a terrible way of learning math. But it is what it is now. I guess that professors are just lazy and don't want to do the actual grading. That's the only reason I can come down to, because the process is so important on here, just as important, obviously, as getting the correct answer. But you take away, when you're doing those homework problems, you take away where you don't know sometimes where you go wrong. Well, this is the solution to it. This is a great solution to figure out where the hell you went wrong on certain answers. We're going to do a lot of just writing out the solutions, writing out the practice problems on the second video. This one is really trying to learn and understand how derivatives work and these few different properties here. Okay, so let's start here. I'm going to split view. Yes, copy and pasting each question over. I don't recommend doing the entire one at a time. I do recommend just doing one question at a time. ChatGPT can get overwhelmed and it be confusing on which number and process you're talking about. So just do one at a time. So I've uploaded the homework, and I uploaded the homework I have over derivatives, and he goes, I'm using Tutor Me, which is a GPT that Khan Academy, great channel, great website. They're one of the founders of just learning math in general. I used them a lot growing up. They have a GTP called Tutor Me, and so it says finding the derivative of x to the fourth to begin. Do you recall what rule we use to find the derivative of a function like this? Let's just say we don't. Let's just say, no, I don't remember the rules for derivatives and how to take a derivative. Can you go over it for me? Over them for me. So let's see if it does. Of course, when taking a derivative of a function, we're looking at how the function's output changes as its input changes. For polynomials, we use the power rule. The power rule says that if you have a term ax to the n, where a is constant, n is the power of x, the derivative of that term with respect to x is a times n times x to the n minus 1. Okay, exponent times the coefficient, exponent minus 1. So for a term like ax to the fourth, you'd multiply the exponent by the coefficient, that's 4 times 8, subtract 1 from the exponent. Given this, what do you think the derivative of 8x to the fourth is? Let's say you don't understand. You're just like, I don't get it. I still don't understand. Can you please explain it to me like a fifth grader? Let's see how it explains. Sure, let's make it really simple. Imagine you have a tiny superhero that can make copies of themselves. The rule for their superpower is kind of like a math game. If your superhero, let's call them X, has a power level of 4, they have a special multiplier of 8, like having 8 magic gems. Here's what they do to use their power. They check their super level power, which is 4. They multiply the number of magic gems, 8, by their super level power, 4. So 8 gems times 4 equals 32. Then they use a bit of their power, so it goes down by 1 level to level 3. So after using their power, they have 32 as their new magic number, and their superpower level goes down to 3. They went from 8x to the 4th to 32x to the 3rd. Can you see how the superhero used their power there? That is an interesting and cool way of explaining things. They're going to use their superpower, obviously, so their levels go down. So it goes down by 1 every time. So the exponent goes down by 1, and you multiply, and since they use a superpower, their coefficient, 8, goes up by 4 times. So 8 times 4 is 32. That is a cool way of doing it. So that means that we're going to change this to red. So that means that 8 times 4, x to the 3 minus 1. Sorry, my handwriting. Which equals to 30. Oops. This is 4 minus 1. So this would be 32x to the 3rd. Wow, that's cool. I see that. What other rules for derivatives are there? Let's look at that. Let's look at the product rule. Let's look at the quotient rule. Let's look at it. Great. Besides the power rule, there are a few more basic rules for derivatives. Constant rule. If you have a number that doesn't change, a constant like 5, its derivative is 0 because it doesn't get bigger or smaller as you change x. Obviously, okay, so as x changes, because it's output, changes of output over changes of input, change of x over the change of y over the change of x, how does y change as x changes? Well, a constant isn't reliable on x, so its derivative is 0. Sum rule. If you're adding two functions together, you can find the derivative of each one separately, then add those derivative. Oh, that's cool. Okay, so if you have f of x and g of x, the derivative is f of x plus g of x. Product rule. Okay. Quotient rule, chain rule. Okay, so we have the product rule and the chain rule. So let's break down the product rule. As shown in number 2. How do we know it's a product rule? Well, simple. There's two terms with x's in there and they're multiplied together, so it's a product rule. Okay, sure, I mentioned the product rule under number 3, so let's focus on that one. Goes through, the product rule is used when you're dealing with multiplication of two functions. It might sound tricky, but it's a step-by-step process. So it talks about the superheroes. Let's call them F and let's call them G. They each have their own special powers. When they team up for a mission, they combine their powers to save the day. The product rule helps us understand how much more powerful they get when they work together, especially when things change. All right, so we have two superheroes. Now they're working together. Here's how the product rules breaks down. First, you take the derivative of the first superhero, F, and leave the second superhero, G, just the way you are. Then you keep the first superhero, F, the same, and take the derivative of the second superhero, G. Combine. Finally, you add these two together. All right, in math language, if f and g are teaming up, which means multiplying their powers, f of x times g of x, the formula for their combined power is getting stronger is f times g of x. Oh, that's actually interesting. Okay, let's pretend f has a power of x squared, just like that, like being able to double anything, and g has a power of x, like being able to add an extra punch. What do you think happens when we use the product rule for these powers? Okay, so then it's just the derivative. So x squared would be 2x, and so it'd be 2x, and then the derivative of x is just 1. Okay, x plus 1. Let's walk through the steps using the product rule when they have their powers f of x. Is that how you do it? F of x equals x squared and g of x equals s. First, we find the derivative of f of x, which is 2x, using the power rule. Okay. Second, the derivative of g of x is 1, because when you have x to the first, you apply the power rule, you get 1 times there. Okay, so it explains it. X, 1 minus 1, so it'd be x to the 0. Anything raised to the 0 power is 1. Excellent. So the derivative of g of x is equal to 1. Now combine them using the product rule. Okay. So we have 2x times x plus x squared times 1. And they did it. 3x squared. Boom. Okay. Okay, that is really cool. Now let's look at it. I don't want to keep writing that down because it's a different question. Awesome. So for the uploaded homework, number 2, we have x. Number 2, let's say I wrote it down here. I wrote x squared times 2 plus, does the order matter? Let's see if it catches it, if the order matters. 2 plus 2x times 2x minus 3. So 2x squared plus 4x squared minus 6x. So therefore we would be at 6x squared minus 6x. So let's take a picture of, I wrote this down here. Let's see if it can check my work. You can't write it down. If you write down the answers with the pen on here, like on a tablet form, and you upload it, for some reason it doesn't read it, which is fine. You can still write it down on a piece of paper. So it's kind of weird. So let's go ahead. Awesome. Thank you. Can you check number 2 for me? I took a picture of my work. Always say please and thank you. I've watched way too many movies. It would be nice to say please and thank you. You always want to be nice to the AI because you never know if somebody takes over. They should remember somebody nice. And also just being, I think we all just need to be a little bit more nicer to each other because there's too much negativity in the world. Let's take a look at your work. You applied the product rule. Derivative of x squared, which you wrote as 2x. The derivative of 2x minus 3 you wrote as 2. Then you combine those. And then combine it. So it read it perfectly. That is awesome. Great way to check your work. Let me check your work step by step using Python to ensure it's correct. We'll see if the derivative you found matches what we compute. So the fact that it checked the work accurately, and if it doesn't, all you got to do is change. You can reference step 1, step 2, step 3, the simplified version or the combined version. It's not going to be 100% every time, but either is a professor or a teacher, so it's okay. It's okay. So according to my check, the derivative is 2x squared plus 4x squared minus 6x, the same as what you've written. Your work is correct. Awesome. And then ask you how you feel about it. What do we need to do to work on it? If you still don't understand, ask, and it will provide. It'll probably. Let's see. I still don't quite understand the process. I need more practice. Let's see if it will. Absolutely. Practice is great. Would you like to try another practice problem using the product rule, or would you prefer to work on a different type of practice problem with different derivative rules? Can you provide me with 3 practice problems for product rule? Certainly. And boom, it provided 3 different practice problems. That is cool. We're not going to do them here, but these are some things that you can do to make sure you understand the material. And then this is just kind of going off, and the fact that it can provide the practice problems is unheard of, and just it's great for studying, because I know as a student, I mean, I paid my way through undergrad with tutoring, and I paid my way through grad school with tutoring, and just knowing just seeing students struggle because they just needed more practice. They needed a practice problem on sometimes the textbooks are so expensive. Sometimes the textbooks didn't show you what was wrong. Like all of the odd questions that had the answers in the back of the book, they just showed you the answers. They didn't show you the step-by-step, but this shows you the step-by-step. These are the different practice problems. And I know professors sometimes hate giving out the answers. Why? Because they do not want the answers to get out, because they keep using the same shit over and over and over again. So they think from one semester to the next semester, they try to preserve it. And that's all just bullshit, and laziness, and it needs to go away. And this is one way that it can go away with professors. All right, the last one is quotient rule. Thank you. Now can we move on to the quotient rule? Please explain how to use the quotient rule. So let's talk about the quotient rule, which is like the product rule, but for division. All right, cool. Imagine you have a pie. Let's call it top pie. And you want to divide it by some number of plates, the bottom pie. The quotient rule helps you figure out how fast the size of pie slices changes as you change the number of plates. Here's what you do. Top times the derivative of the bottom. First, you keep the top pie as it is and multiply it by how quickly the number of plates can change. Bottom times the derivative of the top. So it's always like the first one, okay. The product rule is the derivative of the first times the second plus the derivative of the second times the first. Okay, subtract, you take the first part from the second part, bottom squared. Lastly, you take the number of plates you have, bottom pie, and square it. So you have the derivative of the first times the second. Instead of plus, you subtract, so minus the derivative of the second times the first, and then you square the bottom. All right. So I actually have a cool little saying is high D low, low D high, square the bottom, and away we go. So low times high times the derivative of the low, which is top times the derivative of the bottom, minus low D high, or high D low. So the top times the derivative of the bottom, square the bottom, and away we go. And we just square the bottom. Excellent. It says it right there. Now, can you show me how it applies to number 3 on the uploaded homework? Again, reference that homework. You got to keep referencing stuff very specifically because ChatGPT sometimes will throw you for a loop. And if you're not specific, it won't remember and it'll just go based off of the last message. So, sure, for the third problem on your homework, you have the function hx equals 3x squared divided by 4x plus 5. We'll call the top part of the fraction u of x and the bottom v of x. Find the derivative of u of x. Before I proceed, I can find the derivatives are. What are? So it asks us what they are. So we've learned. So it's 6x and 4. See if you just write it. You probably should write derivative of ux equals 6x and the derivative of vx equals 4, but it automatically did it. Again, sometimes it could be finicky to where if you just are very vague about it, it won't grab it, or it won't understand that 6x was, it might swap it, where the derivative of vx, which is 4x plus 5 equals 6x, which we all know that's not. So you got to be specific. I got lucky, and I wanted to show you, hey, it can work. Plugging in what we found, we have, all right, so let's write, I'm going to write this down. I'm going to write 6x times 4x plus 5 minus 3x squared times 4 divided by 4x plus 5 squared. So let's see if it will catch it if I do something wrong. Let's say 6x plus 4x is 24x plus, or 24x squared plus 30x. Let's change that to 12x squared plus 12x squared over 4x plus 5 squared. So we add 24 and 12. So we'll go 36x squared plus 30x divided by 4x plus 5 squared. So we added instead of subtracted, and let's see if it catches it. So let's come over here. We're just going to go ahead and show you if it can catch it. We're going to put this at full screen too. Okay. Oh, I got to retake the thing. Retake the picture here. Next, let's see if it will catch it. Because as you can see here, instead of subtracting, we can annotate here. We subtracted here and added here. And let's see if it catches it. Here is the simplification of the derivative. Let's see if it catches. Be great if it did. Let's see. You worked through the quotient rule and simplified it. Let's check your simplification step by step to ensure it's correct. I'll compute it and then we can discuss the results. So it's computing, analyzing. This is the big feature that is just, it's pretty good. It could catch it just as well as a TA, a tutor. Sometimes if it's your friend helping you, your mom, your dad, like a professor sometimes it's not always 100% whoever checks it. And honestly, neither is ChatGPT. We'll see if it actually can read my handwriting. I know I have terrible handwriting, so the fact that it might be able to would be great. Let's see. It looks like the simplification is a bit different from what you provided. Would you like to go over each step by step to find out where the difference is? Yes, please. So it's going to start over, and it's all right. Sometimes it does, and it might take a while, a little bit longer, but this isn't something, again, that's a quick fix. This isn't a, hey, I can learn something a lot faster. Sometimes it takes a little bit longer, but it's pretty accurate, or it's pretty good way to learn. That's all. That's what I got to say here. So the quotient rule formula is that. So okay, so it wrote it down. Plugging in what we found, the formula becomes that. Okay. Now we distribute and simplify it. So it doesn't just go from where it always starts over. Like it really does, which is good because so you can see everything. It's nice to see the entire problem from start to finish. So combining terms in the numerator, 12x squared plus 30x, we can factor out a 6x, and that's to simplify for each step carefully shows the quotient rule and simplifies the algebra. Where in the steps do you have questions or feel unsure? I don't know where I went wrong on my simplification. All right. It's almost like starting over, so let's see if it catches. Let's see if it can really show you where. You can look and obviously see each step that I wrote down, or that you wrote down, and check it back and forth. But let's see if it can show you by itself. Thinking, still thinking. Still thinking. The GPT must be a Monday. You know, everybody thinks a little bit slower on a Monday, and I always find this fascinating. The GPT, the free version, the 3.5. It's always way faster than all the other. I don't know where I went wrong, and it didn't do anything. Can you please check to see where I went wrong? The simplification. Let's see. It's kind of annoying that it does this. Let's redo it. Sometimes it takes a couple things. It's not quite there yet to see. Let's carefully go through your written work. Okay. Actually combine like terms. Boom. Okay, so it shows it here, right? This is a step where it looks like the error might have occurred. You wrote 36x squared plus 30x. However, it seems there is an accidental multiplication of 12x term by 3. Instead, the numerator should remain 12x squared plus 30x after combining like terms. Boom. Cool. Thank you. All right. So this is a great way. It did a pretty good job. Again, it's not the bet. Sometimes it's difficult to talk to it and talk to it about checking your work. It checks it, but you gotta ask it in the right way. And she can be a little finicky sometimes on the answers, as you can see. But overall, it did what it did. It checked the answer. We got the right answers. It explained a cool way of the superhero powers of explaining what um, what it really is, what a derivative really is, and how to solve it. Um, I think I think it's a great tool. Again, it's a good refresher, a good way to check your work, a good way to get practice problems. As you can see, we can go through and ask it, hey, I didn't really quite understand that quotient rule. Can you provide me with three or four more examples? I wouldn't recommend more than 5. It can get a little weird when you start doing 5, 10, 15, 20. Just as you can see, even with 1, it doesn't quite answer it as cleanly as you would like, but it's a work in progress. It'll hopefully get better every day. If you really enjoyed this or want a topic that, if you want to have a topic that we need to cover, just hit me up on X at the Tutor Justin, or comment down below of a topic or a problem you want to cover. I hope everybody enjoyed this video, and stay tuned for part 2, where we're going to talk about the chain rule and a little bit more advanced derivatives to see how well ChatGPT can. It did a fairly good job on just the basics, so let's kick it up a little notch. All right, I hope everyone has a good day. Peace.